Assalamu alaikum everyone, I hope you guys are doing well. So in this video we are going to be looking into permutations, and the type that we're going to be looking into is type 1, where the position of one or more letter / object is fixed. So I have some past paper questions. We're going to start off with some easy questions and then gradually increase the difficulty level. So this question right here, as you can see, is from October-November 2013, paper 6, variant 2. So it says the 11 letters of the word remembrance are arranged in a line. Find the number of different arrangements which start and finish with the letter M. Okay, so since we're talking about how many letters, we're talking about 11 letters. Let's make 11 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, now, what is the restriction? The restriction is that the arrangement should start and finish with the letter M. So that means in the first place, we got to have an M. And in the last place also, we have to have an M. Now, in between, anything can happen. That means there's no restriction in between. So that means as far as these spaces are concerned, they can be arranged 9 factorial. Why 9 factorial? Because that's the number of letters that we're left with, divided by, so 9 factorial divided by, now how many letters are repeating? So we're talking about 2 R's. So there are 2 R's that are repeating. So remembrance, yeah, so that's 2 factorial. And we are talking about 3 E's. So that's 1, 2, 3. So that means we have to divide it by 2 factorial and 3 factorial. So let's work this out, see what the answer is. Get your calculator in the numerator. So I suggest that you write it as it is, okay? So 9 factorial divided by 2 factorial, which is as good as 2. So might as well just write 2. And the final answer is 30,240. And there you go. That is the correct answer. Okay, and now as far as the M's are concerned, because they're both the same, so it's not like we can swap around the M's and make a different arrangement. It'll still be the same arrangement because the 2 letters are the same. All right, so that was one question. Like I said, we'll start off easy and then gradually increase the difficulty level. So here's another question, also from October-November 2013. Let's see what this says. Find the number of different ways that the 9 letters of the word aggregate can be arranged in a line if the first letter is R. Okay, so how many letters are we talking about? We're talking about 9 letters. So let's start by making 9 blanks. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So if the first letter has got to be R, so let's fix an R over here. Okay. Now, as far as the remaining positions are concerned, anything can happen. So that means for these spaces, we can have how many different arrangements? We can have 8 factorial. We can have 8 factorial arrangements. Okay, but then let's see, there's got to be some repetitions. Okay, so clearly I can see, and I'm sure you can also, that A occurs twice, so that means we got to divide by 2 factorial. G occurs 3 times, so that means we also have to divide by 3 factorial. So all of this is the denominator, okay? And then let's cross out the 3 G's. And then E also occurs twice, so that means we also have to divide by 2 factorial. So basically, a nicer way of writing this would be 8 factorial upon 2 factorial into 3 factorial into 2 factorial. Okay, so let's work this out, see what do we get. So 8 factorial, the numerator, divide by 2 into 3 factorial into 2. So we have a total of 1,680 arrangements. And there you go, that's the answer. So fairly easy question. Now let's spice things up a little. So this says a committee of 6 people is to be chosen from 5 men and 8 women. One particular committee consists of 5 women and 1 man. Okay, so I should mention here that I have taken out only parts which involve permutations such that the position of one or more object is fixed. Okay, so this is just a specific part of this question. So what we're going to be focusing on is only this part, where it says in how many different ways can the committee members be arranged in a line if the man is not at either end. So that means if there's no man at either end, that means there's got to be a woman. And how many men and women are we talking about? So we're talking about 5 women and 1 man. Okay, so this has already been done. We're just focusing on, like I said, a very specific part. So how many people are we talking about? We're talking about 6 people. So let's make 6 blanks. 1, 2, 3, 4, 5, 6. Now do keep in mind that since a man can't be at either end, so that means at this end, there's got to be a woman, and at this end, there's got to be a woman as well. Now, also keep in mind that we have 5 women to arrange and 1 man. So always settle the restriction first. So the restriction for the first place is that there's got to be a woman, so that means we have 5 options. For the last place, there's got to be a woman as well, and that means we have 4 options. Now, in between, anything can happen, so we have 4 people, and these 4 people can arrange 4 factorial number of ways, or 4p4 also. That's perfectly all right. So that means 5 into 4 factorial into 4. And once again, there's no, because we are dealing with people, not once again actually, in this question, because we're dealing with people, every person is different from the other, so we don't need to consider any repetitions. So 5 into 4 factorial into 4, that gives us 480. So there you go. That's the answer to this part. Okay, now another question. This is from May, June 2015. Now things are getting slightly complicated, but that's how it works. Rachel has 3 types of ornament. Okay. She has 6 different wooden animals, 4 different seashells, and 3 different pottery ducks. All right. Rachel displays 10 of the 13 ornaments in a row on her windowsill. Find the number of different arrangements that are possible if she has a duck at each end of the row and no ducks anywhere else. Okay. That's interesting. So let's write the information down. So she has 6 wooden animals. All right, I'll just write wooden. She has 4 seashells, and she has 3 different pottery ducks. Okay, now remember, she's going to display not all 13 of them, but only 10 out of the 13. So that means let's make 10 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right, now be patient with questions like this. All right, if you rush into it, I can't guarantee whether you'll get them right or not, but if you're patient, then yes, I can give you some guarantee. So what's the restriction? Remember to always settle the restriction first. The restriction is that she has a duck at each end of the row and no duck anywhere else. So that means there's got to be a duck here. So let's put a D here, and there's got to be a duck over here. So that means for the first place, she has 3 options, and for the last place, she has 2 options. Now this is where it gets interesting. Do keep in mind that now she still has 6 wooden, 6 wooden animals, 4 different seashells, and she still has 1 pottery duck left. Okay, so do keep in mind that only 2 of them are gone, so that means there is still 1 left. But the thing is that she can't have a duck anywhere else. So that means now for the remaining 8 places, she is only going to choose from these 10. Okay, she is only going to arrange basically these 10. So how do you arrange 10 objects if you have room for 8? You do that by simply doing 10p8. Okay, so there you go. 10p8 is what's going on in between. 3 into 10p8 multiplied by 2. So I repeat, she can't use the pottery. She can't basically arrange the pottery duck because the question says so, that she's only going to have a pottery duck in the first place and the last place, and that's it, nowhere else. And now she is down to 10 objects and she has room for 8. So the way that she can arrange 8 out of 10 objects is basically through 10p8. And because we're talking about arrangement, that's why we're using p. So 3 into 10p8 into 2. Okay, that's a freakishly big answer, but don't freak out. That's what it is. It's 10,886,400. And there you go. That's the answer to the first part. Now let's have a look at the second part, which is basically the third part of the question. All right, now let's see what that says. So let me number these parts. Okay, so this part says that she has a duck at each end of the row, and wooden animals and seashells are placed alternately in positions in between. All right, so once again, there's a lot of patience that's required here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, no, not 10. Yeah, 10. Okay. So the condition is still the same, that she has a duck in the first place and the duck in the last place. So that means 3 options here, 2 options here. Now remember that she is now going to arrange, because here also the duck is at the first and the last, at the beginning of the row and at the end of the row. So she is now going to arrange 6 remaining wooden, wooden animals and 4 different seashells. But she has to do it alternatively. That means she's going to have a wooden animal and then a seashell and then a wooden animal and then a seashell and then a wooden animal and then a seashell. Okay? So this is how it's going to work basically. So if let's say she starts with a wooden animal, then she's got to have a seashell All right, now let's do part 2, which is actually part 3 of this question. So part 3 says that she has a duck at each end of the row and wooden animals and seashells are placed alternately in the positions in between. Okay, so she still has a duck at each end of the row, and in between she is only going to have wooden animals and seashells, but alternately. So that means she's going to have a wooden animal and then a seashell and then an animal and then a seashell. That's how it's going to work. Okay, so let's start by making 3 blanks. Okay, since we're talking about, oops, sorry about that. So since we are talking about 10 places, so like I said, let's start by making 10 blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, now let's place the ducks where they're supposed to be. So a duck in the beginning and the duck at the end of the row. All right. Now, in between is where things can get slightly technical. Now, do keep in mind that she still has 6 wooden animals to choose from, and she has 4 seashells to choose from, okay? So that means if, let's say, after the duck, she places a wooden animal, then she has to place a seashell. That's how you alternate. And then a wooden animal, and then a seashell, and then a wooden animal, and then a seashell, and then a wooden animal, and then a seashell again. Okay. So first, let's talk about the ducks, all right? So in the first place, since he has 3 ducks, that means she has 3 options. And then in the last place, since 1 is gone, so that means now she's down to 2. So that would be 3 times 2, okay, as far as the ducks are concerned. All right, then let's talk about what's going on in between. So in between, let's talk about the wooden animals first. So notice that she has 6 wooden animals, and how many has she placed? How many has she arranged? She's arranged 1, 2, 3, 4. So how can you arrange 4 objects from a total of 6? That would be 6p4. And now let's talk about the seashells. So she has 4 seashells and she has arranged, let's see how many of them, 1, 2, 3, all 4 of them. So that can be done 4p4 number of ways, okay? So that means this is how she can have ducks in the end and in between wooden animals and seashells. But there is a problem. Not a problem, actually. This is not the final answer. Why is that? Let's see. So if I multiply, so what do we get? We get 51,840. Okay, so we get 51,840. But what if I told you that you have to multiply your final answer by 2 to get the final answer, which is going to be, let's see, so answer multiplied by 2, 103,680. Now, I know what you're probably thinking, that, wait a minute, what's the logic behind multiplying by 2? Well, here is the logic. So let me copy what I have done here. In fact, let me duplicate it and show you guys what the logic is. So the thing is, notice that we start, after the duck, we placed a wooden animal, but there's nothing in the question which says that after the duck you got to have a wooden animal. All you have to watch out for is that you have to make sure that it's done alternately. So that means after the duck she could have had a seashell and then a wooden animal and then a seashell and then a wooden animal and then a seashell and then a wooden animal and then a seashell and then a wooden animal. Now, once again, if you pay close attention, the way that we arrange the ducks remains the same. That is basically 3 times 2. And now let's talk about the way that we arrange the seashells. So here we have 1, 2, 3, 4. So we've used all 4 of them. So that would be 4p4. And how many wooden animals have we used? 1, 2, 3, 4. 4 again from a total of 6. So that would be 6p4. Now, if you look at this calculation and if you look at the one that we did earlier, notice that they're both exactly the same. So you don't have to do it again. Well, it's a good idea if you do it again, you'll have more clarity. But all you got to do is multiply it by 2, because the same is possible once if you start with a wooden animal, and it's also possible if you start with a seashell. So I hope it's clear. The final answer is 103,680. Now that's it. Let's do another question. Here is a fairly recent question, and this is actually a very nice question because it's basically testing a concept which is not very frequently tested. So we're talking about how many letters? We're talking about 11 letters in the word requirement, in which there are exactly 3 letters between the 2 R's. Okay. So that means we not only have to keep the R's fixed, but we also have to keep the number of letters in between the R's fixed also. So let's start by making 11 blanks. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now remember to always settle the restriction first. So we got to have an R here, and we got to leave 3 spaces and then an R. Okay. Now, what are we left with? We're left with 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're left with 9 empty spaces, which can be arranged 9 factorial number of ways. And then don't forget that the letter E, other than R, is perhaps the only letter that is being repeated. So that would be divided by 3 factorial. But if you leave it here, which I'm afraid a lot of students will, that's incorrect. Why? Because the question doesn't say that the 2 R's with 3 letters in between should be in the first 2 places. Okay, there's nothing in the question which says that. So you have the first, second, sorry, not the first 2, the first and the 5th place. There's no such condition mentioned in the question. So that means they could be in the 2nd and the 6th. They could be in the 3rd and the 7th. So let's see all the possible positions. So let me number the blanks first. Now let's see all the possible positions of these 2 R's with 3 letters in between. So the obvious one is the 1st and the 5th. So that's 1. Now keep counting with me. Then the 2nd and the 6th. So that's the 2nd. And then the 3rd and the 7th. So that's the 3rd possible position. And then the 4th and the 8th. So that's the 4th. And then the 5th and the 9th, so that's the 5th, and then the 6th and the 10th, that is the 6th, and then the 7th and the 11th, and that's it. So that means these 2 R's with 3 spaces in between or with 3 letters in between can actually be in 7 different places. Okay, so let's see one more time. Here's 1, 2, 3, 4, 5, 6, 7. So that means all I have to do is, with my answer, multiply it by 7. And there you go. That will give you your answer. Let's see what that is. 9 factorial divided by 3 factorial multiplied by 7. So we're looking at 423,360. And there you go. That's the answer. Let's do another question. Here we have, in how many different ways can the 9 letters of the word telescope can be arranged? So there are exactly 2 letters between the T and the C. So once again, very similar to the question that we just solved. So how many letters do we have? We have 9 different letters. 1, 2, 3, 4, 5, 6, 7, 8, 9. I do encourage you guys to pause this video and try this question yourself before I solve it. So here is the first letter. And then remember, we have to keep how many letters in between? We have to keep exactly 2 letters. So here is C. So it's a good idea to number the spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. So from the 9, 2 are gone. So that means now we're down to 7. So that's 7 factorial. And I believe the letter E is repeating 3 times. So that would be divided by 3 factorial. Is there any letter that's repeating? No. Now, once again, there's no such thing in the question which says that the T and the C have to be in the 1st and 4th place respectively. So this is 1 place, this is the 2nd, this is the 3rd, this is the 4th, this is the 5th, and this is the 6th. So that means these 2 letters with 2 letters in between can be in 6 different places. Okay? But another catch in this question. If you leave it here, which once again I'm afraid a lot of students will, you won't get full marks. Why? Because here, let's compare this question with the previous one. Here, we were talking about 2 R's. Now, 2 R's, they're both the same letter. So that means even if I swap the places of these 2 R's, it would still be the same arrangement. Okay, so swapping these 2 R's, if I do that, you won't notice any difference. But here, if you think about it, T and C are actually different letters. The question did not say anything where it's hinting that T should be first and C should be second. It just says that there's got to be a T and the C and with 2 letters in between. Okay, that's it. So that means the same arrangement is possible with 6 number of different positions when you have C first and T after the 2 letters. So that means all I have to do is take this answer and multiply it by 2. Okay, so this is what will give you the correct answer. So you got to think, you got to be able to think on your feet. Now, this is not easy. Nobody is saying that this is easy. It's tricky. But the only way that you will be able to do these questions correctly is if you practice. Okay, and you got to practice every single kind there is. And I encourage you to download the PDF and try questions yourself. Try at least all the type 1 questions. And then once the type 2 video is out, you can try type 2 questions as well. So there you go. 10,080 is the answer. Okay, now the last question. The reason why I have chosen to do this question is because this involves probability. So let's see what it says. The 8 letters in the word reserved. So let's start by making 8 blanks. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Are arranged in a random order. Find the probability that the arrangement has V as the first letter and E as the last letter. Okay, so the only difference in this question is the fact that this is a probability question. So remember, the formula that we use for probability will remain the same no matter at what stage of life you're at. It's basically the number of favorable outcomes, the number of outcomes where the condition given in the question is met, divided by the total outcome, which is basically without any restriction, without any condition. Okay, so what's the condition? The condition is that there's got to be a V first and E as the last letter, not at the two ends. It's just V and E, so if we swap, we can't do that. That means we haven't fulfilled the condition. Now, in between, anything can happen. There are six letters left. Not sure if they're different. Let's see. So there we have two R's. Okay, so let me write it here. 6 factorial divided by 2 factorial. And what else? I think E reserved. Yeah, okay. So 1E, we've used 1E. All right, so that means there are still 2 E's left, which are repeating, so into 2 factorial. So that would be 6 factorial divided by 2 factorial into 2 factorial. Let's see what that is. That is basically 720 divided by 4, if I'm not wrong. 6 factorial. Yeah, so that is equal to 180. Now 180, these are your favorable outcomes, okay? So these are basically the number of ways we have fulfilled the condition, okay? Now let's talk about the total number of outcomes. The way that we can work out the total number of outcomes is 8 factorial because there are a total of 8 letters, and divided by 3 factorial because there are 3 E's, into 2 factorial because there are 2 R's. Any other letter that is being repeated? Nope, I guess that's it. So let's work this out. 8 factorial divided by 3 factorial divided by 2 factorial, which is 3,360. So the favorable outcome 180 divided by the total outcome, which is 3,360. Let's cross this out, see what do we get. 180 divided by 3,360, and the answer is 3/56, which is the correct answer. All right, so that's it for this one, fellas. I hope you have now gotten a good grip on at least these type of questions. Like I said, I encourage you guys to download the PDF and solve the remaining questions. I'll see you in the next one. Until then, take care. Bye-bye.